Hello everyone, today I'm going to teach you how to convert octal numbers into decimal numbers. Don't worry, it's a lot more simple than you might think, and I'll also explain why it mathematically makes sense to do it this way. So, let's start with an example. Let's choose the number, what do we think? 7,055. Let's do this. So to convert a non-decimal number into decimal, all we need to do is get the number in a place, so separate it into this place, this, and times it by the base of that number system to the power of which place it is, starting at 0. So 0, 1, 2, 3. Now, let's do this and see it in action and see how it works. 7,055. Great. Times 8. Now this is times 8 to the power of 0, 1, 2, and 3. And let's see what these equal. Before we do that, let's have a think about why this makes sense. Well, in the decimal system, each place, when you go up, goes up by a power of 10. So the first place, you have 0 to 9. The second place, you have 0 to 9 again. But each of these is actually representing a 10. So you have 1, 2, 3, 4, 5, but 5 is actually 50. So it's 5 times 10. The next one over from that is the hundreds place. So a 5 there would be 5 hundreds, or 5 times 10 times 10, which is 10 to the power of 2. Let's do this for ourselves. 5 times 8 to the power of 0. Well, anything to the power of 0 is 1, so this is 5 times 1, which is 5. And if you think about it, we don't really need to write this one down here, because anything in the first column, it's just going to be itself, essentially, in this number system. But let's go to the second number. This is 5 times 8 to the power of 1. 5 times 8 is 40. If you remember your times tables, you'd be faster at that. We have 0 times 8 to the power of 2. And if you remember, 0 times anything is 0, because you can't have nothing times a thing. You can't have nothing amount of a thing. Now 7 times 8 to the power of 3. Well, let's do that on our calculators now. 7 times 8, which is 56, to the power of 3, which is 3,584. Now, how do we get this number and turn it into our decimal number? Well, all we do is we add it together. So if we look in the leftmost column, we have 4 plus 0 plus 0 plus 5, which is 9. Then we have 8 plus 4, which is 12, and carry the 1. We have 1 plus 5, which is 6, and we have a 3. So 7,055 in base 8 is equivalent to 3,629 in base 10. Now don't just take my word for it, you should use an online converter just to test for yourself if these numbers are accurate. When you write your own number, do all the working out, do everything like I told you about, and test it against a converter to see if you're right. And I'm going to do that right now. And my answer does seem to be correct, and hopefully my logic is correct also. Let's briefly go over how this actually works so that you can apply it to other number systems, because this also works for things like hexadecimal, or binary, or ternary, or quinary. So let's talk about it. When you're doing this, all you need is the number of these places. So a 5 or a 5 or a 0 or a 7 times the base of the number system that it's in to the power of the place that it's in, starting at 0. And that gives you it in decimal. And then you get more of these, and that gives you the decimal numbers for each place, and you simply add them together, and that gives you your converted decimal number. Apologies for my bad handwriting. So that's how it works. So you can actually use this for other number systems. So you can use it for times 16 if you're converting a hexadecimal number into decimal. Thanks so much for watching. I hope this video helped you, and I hope you continue to study hard.